Hi all, my name is Renjith Ramachandran. I'm an independent researcher and I work as a solutions architect. Today I'll be presenting on my paper, Building a Log Stack Trace Framework for Microservices Architecture. So today's agenda, Introduction to Microservice Architecture. Sorry, I'm not sure. Introduction to microservice architecture, complexity of microservice architecture, logging in microservice architecture, distributed tracing and logging, challenges in distributed logging, what are current researchers and what are those outcomes of those researchers. So the framework, like the log stack trace framework, what are the components of the framework, internals of the framework, the output log structure, advantages of the framework, future scope, references, questions. Last decade saw a burst in the use of microservice architecture. Most of the enterprises are on monolithic application. So monolithic application is like a huge application which renders the UI, which has business layer, the database layer, and everything into one application, which was very time-consuming to deploy, build, run it in local and all that stuff. So to overcome the challenges of monolithic application, enterprises started moving to microservice architecture. So microservice is like a small services which run independently. So they provide a lot of agility and scalability. Compared to monolithic application. And with the advancement in the containerization and orchestration tools like Kubernetes, microservice architectures have become very popular. Like a lot of enterprises are moving to microservice architecture. So complexity of microservice architecture, as applications started growing and with advancements in the digital world, a lot of enterprises moved to microservice architecture, but at the same time, the complexity of microservices architecture also increased. So the concept was like one service will do one specific operation, and it will have its own persistence layer. It won't be sharing a persistence layer with another microservice architecture. So as enterprises started building microservice architecture, following the microservice architecture and building microservices, it ended up like a lot of services. And to solve some of the limitations with the microservice architecture, new frameworks were developed. It is still famous, but still there are challenges which are solved by following building new architecture patterns or by building some frameworks. So for example, Saga pattern is architecture pattern which was developed to solve the consistency issue with the microservice architecture. So on the right side, you can see the diagram. There are 6 microservices in this. It's a simple flow, here there is a microservice which talks to 2 other microservices. Each microservice talks to other microservice. It has one microservice 5 talks to our external system. Microservice 4 and 3, they have their own databases, and that's how. It's a sample view how a microservice would look like, how they talk and how the data flows. So in microservice architecture, there are different logging frameworks used, like a log4j, SFL4j are some of the known ones, commonly used ones. There are different logging levels, like a severe, warning, info, conflict, fineness. So severe is kind of like, okay, there is a major error, we use severe or error to show, capture those logs. Warning is warning messages. It's not crucial for the execution of the program for the debugging purpose. Different tools are available to aggregate logs from services. And logging is crucial for traceability. If you are running a Java program or a JavaScript program, you need or a Python program, you will add a lot of loggers to trace your program to see how the output looks. So in a microservice architecture, the complexity is like it can have a lot of microservices. So an enterprise can end up having thousands of microservices, or maybe in hundreds, but as they scale, there can be multiple instances of the service running, which can have thousands of nodes running at any point of time. So distributed tracing and distributed logging are two important concepts in microservice architecture. So distributed tracing involves the process of monitoring, profiling, and logging the execution path to a distributed application in runtime. So on the right side, you see diagram from Uber engineering. It shows the service topology of Uber showing hundreds of microservices. So all the dots, bigger or smaller, it indicates one microservice. So if you see if one service talks to other one, that talks to the next one, so the chain keeps growing, and it becomes if you want to trace an issue, that's where a distributed tracing comes into picture, where you go into each one of the calls and see you'll be using that to find the errors or use that for any latency related issues or any other issues with that chain of calls. So distributed logging is a method of collecting, managing, and analyzing log data from multiple sources across distributed systems. So in the same context, as is shown in the diagram. So if you want to collect logs from all this chain of services, you'll have to aggregate the data and put it into a system and use that for the analysis. So there are different open source tools and also proprietary tools from different vendors available to do that, both the distributed tracing and to some extent distributed logging. So the main research or study was on the distributed logging. So when an error occurs, same in the case of this diagram, say there is an error occurring in this microservice. So if you want to capture the logs of all the services in the call trace, it will that's the main challenge. You'll have to say if there are 10 calls, 10 services involved in that call, in that chain of calls. To collect all the logs from all the services and to find the root cause of the issue is always a challenging part. One service may be invoking the second service, passing certain parameters, and the second one will be calling third one, passing another set of parameters. So you need to know all the data that was passed, which ultimately caused the issue. It may be a data issue, it may be a server issue, something of that sort, which will have to trace all the way back to the place where the call originated. So log details would have only limited information. This is like you saw in the diagram, there can be hundreds of microservices scaled to multiple instances running, and collecting the logs and tracing the issue all the way back to the origin is a challenge. And as I mentioned, there are multiple log levels. So during that process, if you want to change the log level, it will generate a large volume of log data, and there can be potential performance impacts. So traditional logging, again, if you use it, has following disadvantages. One is a limited visibility. So you will be able to get logs from the service that had issues. But if you want to get logs from all the services in the chain, it will be a challenge. Then a limited error context, same as visibility, your error or the error information will be limited to the service which is having issue. But for all the services before that chain, there will be a limited error context. inconsistent logging level. So there can be different logging levels for each service. So if in one service is not consistent or in the same logging level as the other one, it can be challenging to collect the data. Error response isolation. So again, like each service will be returning different response. So you can, to some extent, return capture the error response for certain services, but if there is inconsistent logging, you cannot capture the error response. So because of this long chain of errors and inconsistencies that can happen, there is complexity in finding the root cause. So you'll have to enable more logs or collect more log data, move it into a different system, analyze it to find the root cause of the issue. And since this is like a lot of services are involved in this flow, it will be generating a lot of log data. So you need more resources to move the data out, do the analysis, and come up with the resolution. So current researchers, they are focused more on the root cause localization and failure classification rather than integrating error traceback with the localization. So main focus is on finding the error which happened on the last service which was there in the trace of calls, and also like the classification of the error, but how to trace back all these errors in the chain and find the chain of events that resulted in that error, and also logging all that chain of events. It's not something studied well. And there are few researches which were done on the same methodology to collect more logs as and when error happens, but those are more related to adjusting the log levels at runtime, which will work in certain scenarios, but when there are a high volume of traffic coming into the system, it will have a ripple effect. Like it can impact the performance of the system because it will be generating a lot of logs. So with the rise of artificial intelligence, a new field called the AI ops is emerging. So there is extensive research on, and there are multiple published papers on using AI ops for doing this analysis, like collecting the logs and using AI ops to identify the root cause. So common use cases are like anomaly detection, root cause analysis, and even correlation. But again, AI ops is still evolving. It's currently being used in a phase of inflated expectations. And also like it requires a lot of data, so collecting the data is a challenge. Enterprise may face challenges with the data quality, like AI ops requires data to be collected in a specific format and specific features collected to do the analysis. And it requires a lot of data, like data quantities, again, issue. Then you need to have a lot of data transformation logics and infrastructure challenges where like you have to collect all this data, do these challenges, do these transformations to make it eligible for an AI ops and use that to extract information out of it. So that's a kind of evolving, but I need to have more studies on it. So the aim of this framework, log stack trace framework, is to provide a simple solution, not to overcomplicate it, a simple solution to overcome the limitations of traditional logging, and also the modern observability approaches like AI ops. Like the framework is to produce only the relevant data for error tracing, and logs from different systems will be collected based on the specific event. So basically, this framework includes, it's little small. So there is a logging framework. So every microservice will have a framework built into it. So there is a logging agent, which will be like collecting all the logs from each of the apps. and it will be pushing into something called a logging app console. So that's how you can integrate this framework into the microservice app, and also you have a sidecar logging agent running along with the application, which will be collecting the data, and it will be sending into um, a system called a log app console, where all this data from different systems will be collected, and it can be used for tracing the uh, errors. So how is it different from other frameworks? So here, like when an error happens, say like there is an invocation happening from microservice app3 to database, and the invocation of the database failed. So that's when this framework will generate the event. So that trigger of that event will have like it will trace back to all the services which invoked it. That way, like that error trace will be the triggering event for the logging framework to collect the data and send it to all the data that it has collected. It will send it to the logging agent, and it will be sent to the logging app console, which means like only during specific events like an error, logs will be collected, but the logs will be collected irrespective of the logging level. It will be collected and sent to the logging app console. So these are the components that are covered. So framework is what that is embedded into the application. Agent is for collecting all the logs. App console is for like a dashboard where all these logs will be collected and used for root cause analysis. So here I've shown a sample application. So MS App 1 is the microservice application 1. So it is having an app 1 method. MS App 3 is a microservice app 3. It has an app 3 method. So app 1 takes a request. It uses logger.log statement, which is provided by the framework. So it is printing the request payload. Then it is invoking method to convert that request payload into another format. And then it is invoking app3. So that's invoking the microservices app3. In microservices app3, it is again logging the request. It is converting that. It is invoking another method to convert that into a different format, and it is invoking the database. Now, the database is throwing errors because of connectivity issue or data issue. So most of the cases, what we do is like we just log what is there in the error, which is like the catch block. But we want to to do the better analysis of the error why the invoked database operation failed. You need to have the logger statements from all the places, like before the formatting was done, before what came into the request, what came into the method, and how the invocation happened and all that stuff. So all the logger or log statements that you see in the screen will be sent to which it will be logged into the log statement, at the same time sent into the a centralized location in a JSON format for better analysis. So the framework will stack and the buffer the entries. Buffer will be cleared at the end of a thread execution if there are no errors. So if there is an error, that's when it will use that captured logs, and it will be sent to the centralized system in the JSON format. And also it will be available in the local logging file. So that way you can, when there is an error, it's not like you have to go and change the logging in a microservice app one. Without changing the microservice, any logging statements in a microservice app one, you can pretty much collect all the log statements which resulted in the error of invoking the database using this framework. So log structure will have certain fields which will help to trace trace the sequence of flows and what the data was passed in each of the layers. So trace ID is a unique ID which the logging framework will generate. So when you start the journey, that's when it will generate the trace ID, and trace ID will be carried forward from one service to other. Container ID is the ID of the container. So like in an Kubernetes or a cloud environment where there are multiple, when your application is scaled to multiple containers because of auto scaling, you will have container ID assigned by like the cloud provider. Using that container ID, you can identify which node in the cloud environment is having the issue. So same applies to Kubernetes or any system that supports auto scaling, whether it's any cloud environment. Then app is an app field name. App is the name of the service which provides produce the log. Sequence is like the execution sequence of the flow. So like the sequence number handling showing the sequence in which it was done. A method is the name of the method which caused the issue. A log is the log statement that is printed at that point of time, and a log TS is the timestamp of the log. So advantages of the framework, easy integration. The framework is available as a library that can be easily incorporated into microservice application. Logs only relevant information. So that was one of the challenges with other frameworks. Like it produces a lot of logs. So here, when there is a specific event like an error, that's only trigger point to generate all the logs which are pertaining to that particular flow. So you don't have to change the logger level at any point of time. You get the complete log end to end. And you don't have to play around with the logging level in production. So an error occurs, you get the complete log. So it logs under relevant information, no complex infrastructure required. Like you don't need infra to collect the log, analyze the log, build the dashboards and all that stuff. You have pretty much neat and clean log data available for your analysis. So automatic log collection during errors without logging update. As I mentioned, like here you are not updating any log levels. So your logging will be still running at the severity level where only errors are being captured. But using this framework, when there are errors, you can without updating any log level, automatically it collects all the logs from service 1 to service and where errors happen, and use that for the analysis. So it reduces for false alerts. So here, like you are getting the right data when an error occurs or any other events of that type happens. So that way, like you are pretty much getting the raw data, real root cause of the analysis. I mean, root cause of the issue can be found using that error. So it will reduce the number of false alerts. So future scope of the framework. So this is like the current flow is mainly for the error scenarios. Like if you want to extend this for any other scenarios, that's something we'll have to do more work, and also whether it can accommodate all the potential use cases. Like there is a disk failure, there is a database not available, or environment comes wrong. So multiple use cases can happen. So how this framework can be extended to those scenarios also. Another scope is to extend the framework for event-driven architecture. So this framework is almost ready for event-driven architecture. So event-driven is like you have services producing events, and you have other multiple services which are listening to those events and consuming it. So this framework can be extended for event-driven architecture also, but we'll have to do more study whether it covers all the potential use cases of an event-driven architecture. And once the step 1 and 2 are done, then this framework can be pushed to a GitHub and bundled as a library to facilitate application integrations. So these are my references. Any questions?